चला तर मग मित्रांनो आज आपण शिकूया की कशा पद्धतीने आपण मूव्हिंग लोड्स आणि आयएलडी हे लर्न करणार आहोत. काय असतात, कसे त्याचे शियर फोर्स बेंडिंग मोमेंट्स मध्ये व्हेरिएशन्स येतात हे आपल्याला आज शिकायचं आहे. तर सगळ्यात पहिली केस आहे त्याच्यामध्ये सिंगल पॉइंट लोड मूव्हिंग ओव्हर ए सिम्पली सपोर्टेड बीम. If a single point load is there and it is moving or it is rolling over a simply supported beam. So what I will do here, I will consider here the point load W somewhere at a distance small y from end A, and I will assume here the section XX acting at a distance small x from left end A. I will assume here for the simply supported beam AB, which is having a span as L, and it is carrying the reactions at A and B respectively as RA and RB. So we are going to start with the first phenomena, that is negative shear force. So for the negative shear force, we are going to calculate here negative shear force at section XX. Then negative shear force here we are going to calculate the first negative shear force at section XX, at any section XX anywhere it is in the beam. So for that I need to know that what are the sign conventions of the shear force. So these are the sign conventions of the shear force. If a force is acting on the left hand side and it is upward, if a force is acting on the downward side to the left hand side, then that force will be written as positive and negative respectively. If the force is acting on the right hand side and it is downward and upward here, then that will be written as positive and negative. Remember these sign conventions. These sign conventions were learned particularly in the SAW or in the WAS. So here we are going to deal with the negative shear force. I will assume here the section XX, and I will take the shear force from the right hand side. So right hand side the shear force will be minus, since the reaction RB I have assumed it is acting in the upward direction, here I will take it as minus reaction at B. And if this load W is moving and it comes in between X and B, then it is moving in the downward direction, right side downward, it is positive, so it is load in between X and B. Now the second thing which I want, that is maximum negative shear force. I need to go for this negative shear force, not only the negative shear force. I want where is the maximum negative shear force, when the maximum negative shear force will act. So to get the maximum negative shear force, since I want the negative value, so I will keep this, I will keep it, that is reaction at B. But I need to neglect this, that is load in between X and B. This I want to neglect it. So I am going to neglect that. So the first condition which I got, there is no load in between X and B. Then where we are going to put that load? The load we are going to put it in between A and X. So there is no load in between X and B. The load is in between A and X. Now if I put the load in between A and X, there is a second condition again arrives, that is I want this reaction RB is also maximum, and it is only possible when that moving load is reaching towards B, and it will means that the reaction at B is also maximum. So I want RB to be maximum. So I want to push that load W near to B. Then only it is going to happen. But once this section XX is going to cross, then reaction RB is what I want. The first condition is not satisfied. That is load comes in between X and B. Hence, what I am going to do here, I will put the load W exactly at this section, such that these both conditions will be satisfied. Now the load is not in between X and B, and reaction RB is also getting maximum. Hence, I will put the load W exactly on the section. Once we put the load W exactly on the section, we are going to calculate reactions RA and RB. Let us do that calculation for the reactions RA and RB. So how to do that calculation? We will assume here summation of moment about A is equal to 0 and clockwise will take it as positive. So I will put my finger exactly on the A. W is moving in the clockwise direction. So it is creating the clockwise movement. So W into X. RB is creating the anti-clockwise direction. So minus RB into L is equal to 0. Hence, I will get here RB as WX by L. Next, summation of Fy is equal to 0. Upward I will take it as positive. RA is moving in the upward direction. W is moving in the downward direction. Plus RB is Wx by L is equal to 0. If I simplify this, I will get here WL minus X divided by L. This is your RA and RB. This we have calculated. Now, once we have calculated the RA and RB, now we are moving for the maximum negative shear force. S max is equal to, I will write down this maximum negative shear force as S max, and it is your minus RB. It is the reaction at B. Only reaction at B. This term we have neglected. So reaction at B is here minus Wx by L. So now once I get this, we are going to draw here the shear force diagram. So for this I will take the projections here. Once I have taken the projections, now I will start the SMD. So for SMD here, we are taking a horizontal line. So for this, here it is 0. How it comes as 0? So I will put it here at x is equal to 0. At x is equal to 0, I will put in this equation. Your S max is equal to 0 into anything, it becomes 0. Hence at x is equal to 0, it becomes 0. And at x is equal to L, here S max is equal to minus W into L divided by L. L will get cancelled, it left with minus W. Minus is there, hence we will plot it in the downward direction. Now the question is that how to join this 0 to W. So let us check that the shear force equation. It is Wx by L. It seems like as a straight line equation. Y is equal to mx plus c. Hence, when join this 0 to W by a straight line. So I have joined it with a straight line. This is negative. And here I will mention it as a maximum negative shear force diagram. So here I will write down the W into L minus X by L, that is the RA. Here I will write down the RB as WX by L. Okay. So I write down that reactions and all those things. Let us move for the next calculation, that is positive shear force. So again, similarly we will go stepwise like this in the as order in the negative shear force. So first we are going to do the calculation for positive shear force at any section XX. Then positive shear force at any section XX is, I put down my hand on the section XX, and for the positive I will take the left hand side. From the left hand side I will take it. That is reaction at A. It is positive since it is acting in the upward direction, which I have assumed, minus any load. Now again I will remove this load W and I will put it here in between A and X. Suppose it comes in between A and X, and I am putting my hand over the section. So RA minus W, that is the positive shear force. Hence, positive shear force will be reaction at A minus any load between A and X. Then again, now similarly here how I get the maximum negative shear force? Here I want maximum positive shear force. And to get the maximum positive shear force, we are going to put it this positive term, that is a reaction at A, but we are going to neglect this term, that is a reaction, that is the load in between A and X. This I am going to neglect it. Okay. So to neglect this, the first condition which arrives, that is no load in between A and X. Then where should be the load? So load in between X and B. Second, this reaction at A is also maximum. Similarly, just how we have done in the negative shear force, only just here for the positive shear force I am performing this calculation. Then for the positive shear force I will write down this S max as plus RA, and RA we have calculated here with the equilibrium equation, that is W into L minus X divided by L. So this is your RA and it is positive. Hence, now I will put the end condition at x is equal to 0. At x is equal to 0, if I put it here, S max is equal to what I will get here, W into L minus 0 divided by L. L minus 0 is L and this L will get cancel. Hence, S max is equal to W. That is the plus W. Okay, the answer comes as plus W. So while plotting this shear force diagram at x is equal to 0, it comes as W here. And at x is equal to L, what is your positive shear force S max? Then that is W into L minus L divided by L. So L minus L is 0. Hence 0 into anything it becomes 0. So how to join this again? Once again we are going to check this equation. Here x is having again similarly y is equal to mx plus c, the straight line equation. So hence we are going to join this with a straight line. That is here the positive. Hence I will mention here it as the maximum positive shear force diagram. Okay. If I clubly join both of these here and here, I will show it here. This is W, this is W. Okay. Here it is 0, here it is 0. This is joined with a straight line like this. Now this is positive, this is negative. So this is called as maximum negative shear force diagram and this is maximum positive shear force diagram. So then up till now we have learned what is the negative shear force and what is the positive shear force that we have learned. Now we are going to learn with the next part, that is bending moment. So in this beam particularly we all know that when this W is rolling towards A, RA is increasing, and when this W is rolling towards B, RB is increasing. Means as simple that when this load W comes over A, your RA is equal to W, and when this load W comes over B, then your RB is W. Means it is not having a static value. So since it is rolling from A to B, that reactions are also varying. So let us consider that instant here as shown in the figure, that is the load is acting at a distance y there, and here it is that the section xx is there. So the similarly, just now how I have done here, the positive and negative shear force and negative I have taken it as the section xx. Similarly, we will go for the bending moment at section xx. So bending moment at section xx will be, I will put my hand over the section and I will go for the bending moment. Remember that for the bending moment, sign conventions will be like this. Here, this one I am going to take it as the sagging, it is positive, and this one I am going to take it as the hogging, it is negative. Simple way to consider, this is the like as a snake. If the symbol was there for the movement and that comes here, sign comes here, then that one will take it as the sagging and that is positive. From this side also section, if it comes like as a snake, then that will take it as a sagging, and other one will take it as the hogging. So here I will put my hand over section xx. RA is creating movement with x in the sagging motion, sagging movement. So that's why here I will take it as the positive plus. So I will write down here moment of reaction RA. Moment of reaction RA about XX section, about XX section, and that is RA into X. It is okay. This one we know that. Next, what we will get here? The load in between A and X was W, and it is creating movement in the hogging sign convention. Here like this. It is in the hogging sign convention. That's why I put it here. It is as a -1, and that moment was W into X minus Y. Okay, this much distance is X minus Y. But here, what I will write down in the wording format, moment of W or moment of load in between A and X about XX. Moment of this load in between A and X above section XX. This is negative. Now once again I want similarly how I have gone for the negative and positive, that as for the shear force S max, that is the maximum positive and maximum negative shear force. Simultaneously I will go for here the bending moment as maximum. So to get the maximum bending moment I need to neglect this minus term. Then and then only, and I need to put it this term, that is the positive term, and then and then only I will get the maximum value. If something is going to subtract, then I will get the decrease the value. So hence this subtraction, this value, this term, I will neglect it. I will put it only this maximum value. Okay. Once this moment of reaction RA is getting maximum, means R here the first condition was there. If I am going to remove this condition, means if I am going to remove this term, means load is in between A and X. So the condition was like that. No load in between A and X. Then where should be the load? Then it should be in between X and B. Okay. Second condition was there. Since this is the moment of reaction RA about XX, so I want reaction RA to be maximum. So here RA is also maximum. And again, both these conditions will be satisfied only when we are going to put this load exactly on the section itself. We are going to put this load exactly on the section itself. So I am going to put this load exactly on the section. So once I put this load exactly on the section, I am having W into L minus X by L. And here I will get maximum bending moment, Bm max I will write down here, that as moment of reaction RA about XX, that is RA into X. And RA is here what we are having, W into L minus X divided by L into X. If I simplify this term, so how I will get here W L X minus W X square divided by L. Again I will simplify. So by simplifying this, what I will get here, it has W X only. This L I get cancel, minus here it left with W X square divided by L. Like this term I will get. Now I will put the end conditions there. So the end conditions are at X is equal to 0. If I put it here at X is equal to 0, then Bm max will be. So here it is 0, minus here it is also 0, it comes as 0. Then if I put it at X is equal to L there, then Bm max will be here. It is W into L minus W L square divided by L. Here it left with 1. That is WL. So WL minus WL, again it becomes 0. Now look at here. If I am going to draw here the BMB, this comes as 0, 0. Then where is the maximum bending moment will occur? So we all know that the maximum bending moment will occur where the shear force is 0. So shear force is nothing but dm by dx. This we all know that. We have learned this in the sum again. So this is equal to 0. Then we will get the maximum bending moment. And maximum bending moment, to get this, here I will write down this bending moment equation, this here. So d by dx of wx minus wx square by L is equal to 0. So now I will differentiate this with respect to x. So I will get w minus 2wx by L is equal to 0. I need to find out the x where it is maximum. So I will find out this x as here. Transfer this wx to this side. So what it comes, okay, I will do it step by step. W is equal to 2wx divided by L here. So let us transfer to this side here. It comes as x is equal to L by 2. Since this w get cancelled, it left with 1. L comes to the numerator and w goes to the denominator. So 2 goes to the denominator. Hence, I will get x as L by 2. It means that the maximum bending moment will occur at the mid span, that is at L by 2. So to get into the maximum bending moment value, Bm max will be I will put it here at x is equal to L by 2. In this equation, I am going to put it at x is equal to L by 2. So here it is W into L by 2 minus W divided by L into L by 2 its square. So here, after simplifying that, what I will get? I will get the maximum bending moment, and that maximum bending moment value, if we simplify it, okay, let us simplify that. That is WL by 2 minus WL square divided by 4L. So here it cancels, it left with 1. So here it is WL by 2 minus WL by 4. Then I will take it the LCM as 4 and I will take WL by 2, WL as common here. So LCM was 4 here, so 2 minus 1. So it comes as WL by 4. This is your maximum bending moment which will occur exactly at the center. So here, somewhere is the center. I will assume here. This is WL by 4. Now, the question is that how to join this, with a straight line or with a curve? So we need to check again the equation here. That is Wx minus Wx square by L. Here x is having order of that degree as 2, since it is a parabolic equation, since we are going to join this with a parabola. And this is our maximum bending moment diagram. So what